So I gave you the link to this website on Friday there, which you should bookmark. Now, I don't know if any of the other lectures that you had in the first semester. I definitely know David Drone, who's teaching you mobile app development. I'm pretty sure he uses this kind of layout as well for his module. And so as we work our way through this module, I'll be adding new cards, as these are called. I'll be adding new cards to this website. This card here, behind that will be the recordings of each lecture. So clearly there's nothing there yet, but I'll update that later this evening after today's lecture. The first topic we'll look at is TypeScript, but I guess before that, I should give you some sort of overview of the module. I don't want to dwell on it too much. We'll get into specifics. I'd prefer to do that, but I suppose I should give an overview. Right. This is kind of the one-liner. I condensed it down as best I could. So what it's saying is there's kind of three parts to this in terms of my objective or our objective for this module. Sorry, no. Just give me 1 sec. The first part is this module is about designing and implementing client-side rendering web apps. Now I need to explain what I mean by client-side rendering web apps. I'll do that in a few moments. The second part of the module or of this statement talks about deploying these client-side rendering web apps, deploying them on a serverless platform. That's kind of a second aspect of it, which we look at. In fact, we'll probably be looking at that in the first half of the module. And the third part of this sentence, bit of a loaded sentence now, but the third part talks about automating the provisioning of the resources required on our serverless platform. So there are those three aspects, I guess: client-side rendering, web apps, serverless platform, automated provisioning. That's what's going to make up this module. It's a very practical-based module, as you will gather as we work our way through it. So I'm going to explain a little bit about client-side rendering in this set of slides. I'm sure you've heard of serverless somewhere along the lines. We will just put a little bit of flesh on that. You may have actually practiced some serverless deployment. I don't know. And you may have also come across the notion of automated provisioning. Certainly any of you that studied the cloud architecture module in the first semester would have come across this idea of automated provisioning. You would have used CloudFormation. We will use something else though. I'm conscious of the fact that many of you have studied the cloud architecture module. Some of you haven't though. So I'll hopefully try and balance both of those groups within this module as best I can. But I'm hoping that you have some, well, we'll see. I was going to say you have some familiarity with AWS, but again, some of you may not have, and we'll try and accommodate that as well. So that's kind of the headline in terms of what we want to do here. Okay, let's talk a little bit about web apps and the architecture of web apps. So the very first generation of web apps were classified, or we can classify them today, although that term didn't exist back then being probably the very early noughties, and even before that, maybe the very late 90s. They would be classified as server-side rendering web apps. As I said, that term didn't exist back then, but today it does exist because we have different architectures. But the notion of, or the idea behind server-side rendering web apps, I'm trying to get it across here in my picture, Like on the left, I have my client, which is really my browser. In the middle, I have a server. This is not serverless now for the moment anyway. And on the right, we have a database. And really, the server is doing everything. So I'm saying here that the server is responsible for generating the user interface. It's responsible for doing any kind of number crunching or algorithms associated with whatever the nature of the functionality of this web application is. Any data processing, it's taking care of all of that. It does it all really. In particular, uh, we're saying that it is actually responsible for generating the UI dynamically. So as the user over here on the left, once they load the web app once they kind of navigate to the web app, the very first request that goes to the server, it'll generate the kind of the home page. It'll generate the actual HTML and CSS, send it down. Browser will display it. The user clicks a link on that, let's say, or enters a text into a text box and hits return, or if it happens to be a web form, they fill out the web form, click submit. For either of those three interactions, clicking the hyperlinks, filling in a text field and hitting return, or filling out a form and hitting return, for either of those three scenarios, the next thing that happens is that the browser is going to actually just communicate back to the server the fact that the user has interacted, and the server does its thing. It processes that request, if you like, and it generates the UI and sends it back to the browser again. And the browser now displays the new page based on the user interaction. It could be the same page with slight differences to it, but the server is going to generate the entire restructured page, if you like. So the server is going to generate the page, and it's always doing that. That was the nature of server side, as in the server. If you take the name, the server was rendering the actual user interface. So that was the first generation of web apps. The next generation, which is what we're interested in, are client-side rendering web apps. And you can see now in my picture that there's a slightly better distribution of the workload that's going on here. Now the browser is actually responsible for generating the UI. Okay. So there's actually quite a lot of JavaScript loaded into the browser. It'll be loaded by the server, admittedly, and that JavaScript is now actually going to be responsible for dynamically at runtime generating the user interface, so generating the various views based again on the user interaction. And so the majority of the communication between the browser stroke client and the server is now in the form of data being sent in this direction or data being sent in the other direction. So that's I'm calling that the second generation. Not too sure if it's strictly speaking second generation or not. The interesting thing is though that okay, certainly server-side rendering was the first generation, but server-side rendering web apps have become very popular within the last, let's say, 5 or 6 years again. So there is a swing back towards server-side rendering. Client-side rendering is still really important, and there's also a mixture of client and server-side rendering. So the kind of the architecture is evolving for sure. Here's so we'll just focus in on client-side rendering, or CSR. This is another way of viewing what's going on now in a client-side rendering web app. And what I'm getting across here is that potentially there are actually two servers at play here. The server at the top, all it is responsible for is sending the initial JavaScript down to the browser. So the way these work now is my user enters the URL of the web app. That request, that URL is going to be directed to this static. It's just a static web server. It's an ordinary plain old web server. And the web server is going to grab the assets, which will be a combination of JavaScript, maybe some CSS, and a tiny bit of HTML, very little though. In fact, it'll usually be a shell web page, and it sends those back down to the browser. There's a lot of JavaScript code though in this response. And the JavaScript code runs in the browser, and it actually generates the opening page, if you like, or the opening view of the web app. And the user interacts then. Again, as I was saying a while ago, the user clicks on a hyperlink if there is a hyperlink available. If there is some sort of data entry required, it does the data entry. If it's a web form, it fills out the web form. And in each of those three cases, the request now, when they hit return, if you like, now the communication is down to this server here. And this server, based on the request, it will communicate with the database, get some data, send some data back to the browser. The browser, then the JavaScript here, takes that data and kind of stitches it into the web page and generates an updated web page. And the communication from there on in, any interaction by the user now from there on in, will either involve JavaScript doing some processing locally and updating the view that's being displayed back to the user, or it will communicate with this server down here, either send data down to the server, which it processes and maybe updates the database and sends back some sort of response in the form of data, or just a straightforward response saying, that's okay, I've received that. And the JavaScript processes that response accordingly. Or the request from the browser to the server will essentially be, get some data for me or compute some data for me. And it does that computation and responds back with data. And again, the JavaScript takes the response and makes the necessary changes to the view that it's going to display back to the user. So the key thing is there's a lot of JavaScript code inside here, and it is responsible for dynamically at runtime generating what the user sees. And this is the type of web apps that we are concentrating on in this module. The server up here then has no role after the initial kind of downloading of the assets, as I'm calling them, to the browser. The server down here, we refer to it as a web API server. And so we are going to be interested in developing the kind of code that runs in this server, although we will be deploying that code onto a serverless platform. Serverless doesn't mean there isn't a server. All it means is we are not responsible for spinning up a server as such, but that's for another day. So web API is kind of a wrapper for a piece of some functionality that is responsible for data processing, algorithm implementation, data validation, all that kind of stuff. All I'm showing you here then is, again, kind of a diagrammatic representation of the communication flow that I was describing on the previous slide. The initial communication is from the browser to the server at the top, which is the HTTP server, the ordinary web server. It responds back with the various web assets. Browser uses those assets to generate a view. And then from there on in, any interaction that the user has with the view, that will trigger typically the browser to send a request to my web API server, either a GET request or a POST request. Is there a POST request somewhere? POST request, some sort of either requesting data or sending data down to the server, to the web API server, does its thing and responds back accordingly. The server then here, as we can see, has no other role from the initial part that it played. Client-side rendering web apps. So I'm dating them back to around the early noughties. Okay, so the very first Gmail was a client-side rendering web app. But these client-side rendering web apps have evolved over the years. The very first generation of client-side rendering web apps were just all JavaScript code. There was no third-party libraries. So we're kind of in the early days of the JavaScript language, if you like. There was little or no third-party JavaScript libraries available to us like there is today. There's hundreds of them available to us today. So, you know, as a developer, you had to write a heck of a lot of JavaScript, and there was no well understood patterns that were recommended for developers to use. So we tended to finish up with very unmaintainable, hard to read spaghetti code, essentially. So it lacked a lot. I'm also saying that the very first generation of these client-side rendering web apps, they lacked addressability. Addressability is this one of these core principles of the web itself. You know, in an ordinary static website, as we click on hyperlinks, we navigate from page to page, just in an ordinary website now, not a web app. But every time we go to a new page, the URL in the browser changes. So each page has its own unique address, its own unique URL. That's what addressability is in the context of the web. Now, the thing with the very first generation of these client-side rendering web apps, we still had hyperlinks available to us, and we clicked on these hyperlinks, but clicking of a hyperlink was just something that was intercepted by the JavaScript code, and it did some processing. The actual URL in the browser never changed. So as we moved around different parts of our web app, the browser's URL did not change. And that was considered a weakness, really, of the web app. Because if I wanted to share a particular view within a web app with somebody, I could not send them a unique URL that caused the other person's browser to go directly to the page that I wanted them to see within the web app. So that was a weakness, although it wasn't considered a major weakness at the time. But that problem has now been resolved. Anyway, in terms of what happened over time, the next major milestone in the history of client-side rendering web apps was the introduction of a single library called the jQuery library. It was really phenomenal in its usefulness for developers, because the jQuery library essentially reduced the volume of code that we had to write as developers. So it was less JavaScript code, whereas up here I'm saying, you know, we had to write a heck of a lot of JavaScript code. So jQuery took care of an awful lot of things for standard kind of issues like cross-browser, cross-platform. I'm talking about here cross-platform ness of our web app. You know, we'd like our web app to run in any browser, not be specific to a browser, and that wasn't the case up here. You know, we had to essentially in our JavaScript code we had to detect what type is the browser that I'm running in, and then run one piece of code if it's browser type A, run another piece of code if it's browser type B. So you the developer, had to manage all of that, whereas now jQuery did it. But jQuery did lots of other things as well. It made lots of other aspects of client-side rendering web app development easier. We still had the addressability issue though. Now, whereas initially and for a number of years, perhaps even decade, but certainly a number of years, jQuery was, as I said, extremely popular, extremely beneficial to the developer community. But it still resulted in us producing fairly unmaintainable code, as well as the lack of addressability. The code itself was quite difficult to manage and understand. And for those various defects, we had the next iteration was the introduction of frameworks to the CSR web app development area. And we refer to these frameworks as single page app frameworks. I won't go into explaining where that name comes from. It'll be explained when we actually start looking at one of them. So these single page app frameworks, so I'm dating them to around 2010, 2011, that kind of fish period. So about 10 years after or the very first client-side rendering web apps. And they solved the addressability problem for us. And they also reduced the volume of code that we had to write. They also enforced a structure on our code, which meant that the code was presumably more maintainable and readable. And the very first one was a framework called Backbone, I think. It was probably the first single page app framework. Not really used that much anymore. In fact, it's definitely not used at all anymore. Um, there were a number of other notable ones, like Angular was also a kind of a revolutionary single page app framework. React is the one that we're going to look at, which again, it's been around since about 2013, 2014. So it's quite old, but its popularity persists. So that's the specific one that we look at. And there are newer ones than React that are also quite popular, like Svelte and Solid would be two notable ones. And each of these frameworks kind of looked at its predecessors and tried to make improvements on them, obviously enough, I guess. But React has stood the test of time, it's fair to say. So that's kind of the whole context, if you like, for this module, or one part of it. I know the client-side rendering, I've explained in very brief terms, I know what client-side rendering web apps are all about. In terms of this module, if we go back to this diagram, there are kind of two parts to it, really, if you like. In terms of the client-side functionality, the stuff that's going to run inside the browser, as I've already alluded to, we are going to be using a single page app framework called the React framework. And really all that framework is, in very simple terms, is it's a JavaScript library for building user interfaces. It's really only for user interfaces. You wouldn't tend to put a lot of behavior, or you shouldn't bury a lot of functionality inside a single page app framework. The functionality really needs to reside on the server side. So we're going to be using React anyway as our single page app framework, or our framework for rendering the UI part of a web app. On the other side, then, on the kind of, well, I have to use the word server side, even though I'm talking about, we're going to be looking at something called serverless. But as I said, serverless does not mean there is no server. There always has to be a server. It just means we don't manage or maintain the server platform. But on the server side, that's where we're going to focus on the AWS platform. So all of our web API stuff is going to be deployed onto the AWS platform. Provides, oh yeah, okay. That's fine. This is an outline of how things are going to flow through this module. So starting on the bottom left, by the way, I haven't said, although it's probably clear from if you looked at all at the website that I gave you, that we are actually going to be using TypeScript a lot in this module, as opposed to JavaScript. I'm not certain whether Frank, who's going to be taking care of the client side, the React stuff, I'm not certain whether he is going to use TypeScript or JavaScript. He's yet to finalize that for himself. But I'm going to be using it, in fact, on the web API, the server side stuff that we're going to be developing. And our assumption is everybody probably has done some JavaScript programming, or certainly would be comfortable doing any JavaScript programming. So I am going to give you a quick kind of crash course on TypeScript, but the assumption is that you're already familiar with JavaScript. And so all really TypeScript is a kind of superset of JavaScript. So we'll spend about a week or two on that. Then we'll start to get the web API stuff, and that's where we will flesh out this whole area of serverless, and we'll also flesh out automated provisioning in the cloud, and as well we'll be talking about some generic cloud related stuff. So that's fine. And then we move on to the client side. That's where React. And at the very end, then obviously we need to integrate our client and our server side code. So that will hopefully come in at the end, where we cover stuff like user account management and authentication, and maybe content delivery network CDNs. Depends really on how much time we have available to us at the end here. So this is very much a little bit of guesswork at this stage first, because we have made some fairly significant changes to this module in comparison to, let's say, what we taught last year and the way we taught it last year, and the order in which we taught things last year. So I'm not certain how much. I'm saying here that there'll be 2 weeks available for this integration section, but there may be only 1 week. Hopefully there'll be at least 1 week, but we'll have to see. Okay, so the module is all about developing single page apps, which is using React, which is on the client side, and then using serverless as the platform for developing the web API stuff, using various AWS services. What software do you need on your local machines for this module? Again, I think I might have mentioned one or two in the message. You're going to need to, oh, sorry. Yeah, I use VS Code. Some of you may be very familiar with VS Code already. VS Code is strictly speaking, it's only a text editor, but it's probably would be more appropriate to call it an IDE, though it didn't begin live as an IDE. But it's the editor stroke IDE that I will use throughout, and Frank will use throughout this module. It's not mandatory that you use it. If you're more comfortable with some other one, that's okay. But if you come across any issues, you're gonna have to solve them yourself. This is possibly, but I would highly recommend getting some familiarity with VS Code, because it's extremely popular in the industry, and it's a very simple installation, really. Number two, you're going to need to install Node.js locally. Now, the screenshot was taken a couple of days ago, so make sure if you haven't got Node.js already on your laptop stroke desktop, and you do need to install it, make sure you take the version. It'll change slightly. It almost changes kind of on a week-to-week basis. Take the version it categorizes as the what term does it use? You see the one over here, it refers to this as the current one, which I think is very misleading. But the current one is experimental, and we want to stay away from that. Pick the one that's stable. It's probably the word I was using for, but well, it does say it's recommended here. But this is the stable version of Node. This is the more experimental. I think to use the word current here was a bad choice on their part, but anyway. So make sure you pick the one on the left. Now, on my own laptop, I am using version 18, and that may seem like a very old one, but version 18 was the one that was recommended, I guess, about maybe 5 months ago. So it's not that out of date, really. But I'm sure version 20 will be fine for what we do. Although, like I said, any stuff that I cover will have been tested off version 18. I might try and test the stuff off version 20 as we work our way through it. I don't foresee any problems really with famous last words. I don't foresee any problems if you have version 20. We'll use Git really as just a resource, and you need to install it if you don't have it. But pretty much every laptop probably has Git automatically installed. So just type git -version on your command line to see if it is installed or not on your machine, and just do your Google search to install it if you do need to. We'll also be using GitHub. You'll be using GitHub for any of your assignment submissions, and you should use GitHub to back up any code, other code that we develop in the labs. The nice thing about VS Code, one of the many nice things about VS Code is that you can open up what's called an integrated terminal within the editor, because we will be using the command prompt to type certain commands, and rather than switching between VS Code and the normal terminal prompt, which is outside of the editor, we can do it all within the editor. Prerequisites. If you haven't already, you need to create an account on the AWS platform for yourself. So just, do I have it already opened up, I wonder? So again, like I say, some of you may not have done any AWS stuff, but just just go to AWS, this website here, and just sign up. Now you will need a credit card to sign up, and because of the nature of what we're going to be doing, which is this serverless stuff, the costs that we're going to incur will be very, very minimal. We do need to keep an eye on it though, but if you follow the instructions that I give you, then there will be very, very minimal costs. For those of you that did do the cloud architecture module in the last semester, you would have used the AWS Academy accounts. I think Richard and Jimmy created accounts for you on the AWS Academy. Now, unfortunately, that does not work for us because the kind of stuff that we are going to be doing, the AWS Academy accounts are not sufficiently privileged to allow us to do what we want to do. So that's why you will need to create your own personal AWS account. But like I said, I don't foresee us incurring more than $10 or maybe maximum of $15, absolute maximum throughout this module. I would it'll be interesting actually at the end of the module to see who has incurred the most and the least cost, but it's really going to be minimal, so I would not be worried about that, provided you follow our instructions. So that's it. Create an AWS account for yourself. You're also going to need to install the AWS CLI. Now, I should have probably, but if you just do a Google on AWS CLI install, the very first link will take you to a page on the AWS documentation, and it steps you through installing the CLI on your local machine, and it gives you the instructions for a Mac versus Windows versus Linux. So it covers all the grounds. So you should be able to follow the instructions yourselves, and it should work fine for you. On the right, then I'm just showing you how do you know whether the CLI has installed properly or not. Usual story, really. Just if you type this command here, it should come back with something meaningful. I don't care what specific version of the CLI you have installed, provided it is version 2 dot something, 2.x. So if you already have the CLI installed, well, if you installed it last semester with the in the cloud architecture module, it'll definitely be version 2.x. But if it happens to have been installed, maybe when you bought the machine, it may be 1 dot something, and that is too old. So you will need to upgrade to a newer version of the CLI. Yeah, this is just the version of Node that I happen to have running when I typed these commands. But like I said, I've already covered that stuff. Version 20, I'm sure will be fine. I am saying here familiarity with the AWS Management Console. Now, those of you that did the Cloud Architecture module will be very familiar with the Management Console. Those of you that didn't and haven't done any AWS stuff won't be, but we'll try and we will try to explain how this console can be useful to us as we're doing our development. And I will be, demonstrating using the console anyway in the lectures. So you can, for those of you that are not familiar with it, you'll be straightforward enough for you to pick up how we can use this AWS Management Console to help us when we're doing any kind of debugging or confirming that certain things have deployed properly for us or not. We could have called this module full stack development. Full stack development is, in truth, it's a more modern term than talking about client-side rendering and server-side rendering. So we could just as well say that the focus of this module is full stack client-side rendering web app development. Now, full stack makes no reference to serverless or automated provisioning, but it's full stack in the sense that we're looking at the client side, the server side, and the database side. Oh yeah, the other point from this from the image really is we know now at this stage that our client side is going to be implemented in React. Our server side, albeit on a serverless platform, is going to involve using Node, and it's going to involve using something called Lambda, which is one of AWS's serverless services. We'll talk a lot about that in a couple of weeks' time. The database that we're going to be using is another AWS serverless service called DynamoDB. DynamoDB is a serverless, non-relational database. The module is 100% CA. There will be 2 assignments, a backend, or probably I should have used backend rather than server side because backend is more is not specific to the platform. So there'll be an assignment focusing on the backend or the web API, and there'll be an assignment focusing on the front end. And the front end one also incorporates the integration of your front end and back end, which is why it has a heavier weighting. Let's see. Oh yeah, that's just a summary slide, which I won't talk through.